The figure shows the variation of electrostatic potential V with distance x for a given charge distribution. From the points marked A, B, C, identify the points at which the electric field is 0 and maximum. Explain your answer in each case. So from this given figure, so they give figure. So the graph is drawn between potential versus distance x, V versus x. So from this graph, we need to interpret and we need to find the value of electric field where the electric field is maximum and where the electric field is 0 from the given points A, B, C. So these kind of the graphical interpretations are very important, especially when we are dealing with the competitive examinations. And to identify the electric field, and first we need to know the electric field and potential relation. Electric field, potential and distance, x relation. Here x is nothing but distance, or x, or sometimes in the textbooks we used to use as r. So the electric field E equal to the negative of dV by dx. So this is also, we can say that electric field equal to negative slope of potential versus distance curve. So if you remember this statement, then it is easy to get it answer. So this is a very important statement from this chapter. The relation between electric field and potential and the distance. Or you can remember, this is one more formula: potential V equal to ED, or potential V equal to EX. So this is also the relation between the electric field and potential and the distance. Usually in the capacitor cases we can frequently use that. Now by using this relation, I wish I would find the electric field at point A, and electric field at point B, and electric field at point C. And at point A, if you can see, the curve is straight line. So here the mention, the curve is just a straight line, and dV by dx is nothing but slope. So what is the slope at point A? I wish I would like to write at point A instead of the electric field at B. At point A, the slope of curve dV by dx, straight line slope goes to 0. If dV by dx is equals to 0, and whatever the electric field at point A, that's value also goes to equal to 0. A simple interpretation. This can be done if you know this relation. If you do not know this relation, then gone case. Now at point B, the dV by dx. Now here you can see the point B. If you can draw slope of that at point B, so slope means just it is having a downward slope. And the slope is increasing slope. Now downward slope, it means the slope value goes to decreases. Now here you can see, we cannot find a value, but I can write that the electric field value dV by dx is at here, it is less than 0, since it is negative downward slope. So if it is less than 0, so the electric field at point B, that is negative of negative slope. So if this value is negative, suppose if I take that is less than 0 or in terms of minus 1, so the electric field will becomes positive. So because the electric field is negative of slope, I should not write like that, but to make you understand. So if the slope value is negative, the electric field value becomes positive. Why? Because the electric field is negative of slope. Now here I can write that the electric field P equal to positive. Now let's find at point C. At point C, the electric field dV by dx. Now if I can draw a curve at there point C, so it is something like increasing slope, positive slope. Now dV by dx is greater than 0. If dV by dx is greater than 0, electric field at point C goes to negative, and here it is positive. And here carefully you understand how it is negative and how it is positive. So these expressions we have written by comparing this is the term. So if the potential value negative, the electric field value becomes positive. If the potential value becomes positive, the electric field value becomes negative. So from the three cases, so these are the three cases, and we need to find where the electric field goes to 0 and where the electric field goes to maximum. So in these three cases, at A it is the electric field equal to 0, and at here electric field is maximum. So like this graphical interpretation values questions are more to solve in the competitive examinations. So try to remember this relation, the electric field relation, electric field versus potential and the distance. Electric field E equal to negative of dV by dx.